So this is part one of organic molecules, and we're going to look at how the structure of these organic molecules is important for cell reactions. So as a review, remember that bonds store energy, life needs energy to adjust to its environment, and life has to have orderly structure, which remember means cells. So first off, what's an organic molecule? Well, these are the molecules that are used to make life. And they're called organic because they have the element carbon, as opposed to inorganic molecules, which don't. And all life, it doesn't matter how simple or how complex, all life is made of these four organic molecules that we're going to talk about. So how are they structured? They have a monomer, so that's a subunit of a molecule. And if you put monomers together, you create a polymer. So the way I kind of think about it is like this. So if a brick is a monomer, then a brick wall would be the polymer. And the mortar would be like the bonds. So when we bond together monomers, we create polymers. Because remember, mono means one, poly means many. So what are the types of organic molecules? We're going to look at four of them. We have carbohydrates and lipids, and these are involved in energy and structure. And these are the two that we're going to look at in part one. And then in part two, we're going to look at proteins and nucleic acids and their role in controlling reactions. So structure and energy. Keep that in mind whenever you're thinking about lipids and carbs. Structure and energy. So carbohydrates are sugars, and they generally end in ose. I'll show you some examples and you can see how that works. So what's the subunit of a carbohydrate? It's a mono, so remember one, saccharide, which means sugar. Another way to think of this is it's called a single sugar. And these sugars are very often rings, like you see here. And now if we bond together a bunch of these rings, a bunch of these monosaccharides, we can make a polysaccharide, which is a much more complex sugar. So what are carbohydrates used for? Well, they provide us with short-term energy storage. So think sugar, short-term. If you eat a whole bunch of sugar, like you drink a Mountain Dew, you get really hyper for a short period of time and then you crash because your body uses that sugar real quick to make energy and then it's gone. Carbs are also used for cell walls. So this stack of wood here is actually made of carbohydrates. This would be cellulose that makes the cell wall of plants. So some examples, the main one to really remember is glucose, and that's because it's going to be involved in photosynthesis. It's what photosynthesis makes. We're going to go through this a lot more later on. Starch, glycogen, and cellulose are also important carbohydrates. These are polysaccharides. Starch, think of potatoes. Glycogen is the glucose in or the carbs that are in your muscles, and cellulose, like we said, makes up cell walls of plants. So how does the structure affect the function of a carbohydrate? Carbohydrates have bonds that are pretty easy to make and break, which is why they're good for short-term energy. And you can, put those monomers together to make these really long, complex chains that are good for structure, like cellulose, really complex carbohydrate. So now let's look at lipids. Lipids are fats, oils, and waxes. So think animal fats, olive oil, beeswax, these are all lipids. So what's the subunit of a lipid? Well, they don't really have a monomer the same way that a carbohydrate does, but they're all made using fatty acids. So if I ever ask what's the subunit or monomer of a lipid, just say fatty acids. What are they used for? Long-term energy storage. So think lipid, long-term, sugar, short-term. So just think when you eat something that's fatty, it sticks around with you a lot longer. And as opposed to carbs, which were used to make cell walls, lipids make cell membranes. And we'll talk a lot more about that later on. And then we should all know, a lot of organisms use fats for insulation and protection. So think like whales and blubber. So what are some examples? The main one to remember are phospholipids. Now you should never forget that this is a lipid, seeing that the word lipid is in the name. And these are going to be really important in making membranes. We also have things like steroids. Now I'm not talking about the ones that athletes take, but these are things that are naturally occurring in your body that make things happen. And these are lipids. This is an example of what a membrane looks like. And each one of these, what I would call a balloon with two strings, is a phospholipid. So again, we'll look at a lot more at these in a later lesson. How does their structure affect their function? Lipids tend to have a lot of bonds. And so if each one of those bonds stores energy, they can store a lot of energy in a molecule. So they're good for that long-term energy storage. They also don't mix with water. So think about, oil and water don't mix. And this is going to be really good for membranes.